Hi guys. Okay, let me try to solve this. So, given that x and y are real numbers, and x squared plus y squared equals 16x plus 6y plus 6, what is the largest possible value of 3x plus 4y? Okay, so, originally when I had first picked this problem, I thought, hey, I'm going to find a way to substitute this into here. But I don't think that's the optimal choice. I think the best choice is to recognize that this is the equation of some kind of circle. It's going to be some kind of circle, like, um, let's just say it's this circle here. Then we have 3x plus 4y. 3x plus 4y is going to be equal to our question mark. So 4y is equal to question mark minus 3x. So y is equal to negative 3/4 x plus question mark. So we need to find the maximum possible value that we could put on a line that's going like this-ish to where it intersects. So it's going to be this line, like, right here, I think. Or it's going to be, like, this line, like, here, I think. Okay, cool. So first off, let's find what circle this is. This circle is going to be, well, let's move everything to one side. X squared minus 14x, and then we're going to add 49 minus 49 plus y squared plus or minus 6x minus 6x, and then we're going to add 9, subtract 9, and subtract 6 is equal to 0. So if we have x minus 7 squared minus 49 plus y minus 3 squared minus 9 minus 6 is equal to 0. So x minus 7 squared plus y minus 3 squared. Then this is 49 minus 9, negative 49 minus 9 is negative 58, minus 6 is negative 64, so it's going to be equal to 64. So it's going to be a circle at center, 7, 3, and the radius is equal to 8. Okay, now we need to find the largest possible value of question mark here, such that it follows this. So we want, if we're just going to draw this a little more accurately, it's going to be like this, it's going to be like this. 7, 3, it's going to be a circle that's around here-ish. Radius 8, oh, okay, so it's going to be like a very big circle. Then we're going to need to find the largest value. It's going to intersect like around here, I think. Let me find, it's going to be where it's tangent here. So it's going to be where, the exact point where it's going to intersect. If I find that, I can figure it out. So it's going to be where it's tangent, so it's going to be a line like this. So there's going to be a right angle. So, we need to find the point, well, okay, so this line is, y is equal to 4/3 x, 4/3. Oh, also I was just thinking it's probably good that I got a square number for the radius. That means I'm doing something right. 4/3 x plus p, just using a random thing. So, we could use that, we know a point on the line which is the center, so we could say y is equal to 4/3 x minus 7, 4/3 x minus 7 plus 3. So our line is y is equal to 4/3 x minus 28 thirds plus 9 thirds. So it's going to be minus 19 thirds. Minus 28 thirds plus 9 thirds. Is that? Yeah. Okay, cool. So this is the line. It's going to intersect with this line at tangent point. So, what do we need to do? We need to go from across the circle, across this line, this way, to figure out this point. So if we have this line here, for every increase in the x, we have a 4/3 increase in the y. Okay, so if we have, we need the distance to be 8, radius equals 8, so 8 is equal to, let's do 8 squared is equal to, 7 minus, how am I going to do this? We have the distance between this point, which is 7, and this point, which is going to be some kind of increase. So I'm going to say just an L increase. So I'm going to say an L increase squared plus 3 minus, and then that's going to be 4/3 L squared, right? Because y is equal to 4/3 L minus 19 thirds. Okay, so we have 64 is equal to 49 minus 14 L plus L squared. Plus, this is going to be 9 thirds minus 19 thirds is going to be 10 thirds. This is negative 10 thirds. 10 thirds. So negative 10 thirds squared is 100 over 9. Negative 10 thirds. So then multiply this times this. It's going to be 40 ninths times 2 is 80 ninths plus 80 ninths plus, wait, did I do this right? Yeah. 80 ninths plus 16 ninths L squared. 80 ninths L. Okay. Let's simplify this. So 64 is equal to, it's going to be 25 ninths L squared. 80 ninths minus 14 ninths. 14 times 9 is 36, 90. It's going to be 126. So 80 minus 126 is negative 46. So negative 46 ninths L. And then it's going to be 49 ninths. Is 441, which is a multiple of 9 actually, I believe. Oh yeah, well of course it is. So is, yeah, so oh wait, never mind. I didn't add that. So that 441 plus 100 is plus 541 ninths. Then we just need to find L. What are we trying to find? Okay, yeah. So then just solve, we get, can multiply by 9 on everything to get 64 times 9, which is 36, and 54, which is 6, 7, 5, 6, 7, 5, 7, 6. So 0 is equal to 25L squared minus 46L. Then it's going to be minus 541 minus 576. 41 minus 76 would be 35. Yeah, yeah, okay, so this is a lot. I have a hunch that this is supposed to be divisible by 5, so let's make sure I did that right. In front of L we have 14, and it's gonna be 4/3 times 10 thirds times 2, yeah, 80, and then 14 times 9 is 126, right? Yeah. Okay, yeah, that seems right. So do I have to solve for L now? Man, man. Okay. L is going to be equal to 46 minus 46 plus or minus the square root of 46 squared minus 4 times 25 times negative 35 all over 50. So this is going to be negative 46 plus or minus the square root of... There's an easier way to do this. I don't need to do all this. I do not need to have to do all this. It's clearly using a circle. Then once we get this circle, we need to find the largest value of this, Okay, so why don't we plug that in here? Why don't we plug that in here, maybe? Um, I have an idea. What if we make this a system of equations? This and this. So we have this is x squared plus y squared is equal to 14x plus 6y plus 6. And we also have 3x plus 4y is equal to, let's call the max m. Why don't we edit both of these? So we subtract 14x from both sides and 6y from both sides. So we're left with x squared plus y squared is equal to 6. And we're going to subtract, oh shoot, no, we can't just do, can we do that? If we change both equations by a certain thing, I think we can do that. I think we can do that. definitely cannot do that now, further looking at it. That's not something we can do. Okay, well, y is going to be equal to negative 3/4 x plus some m here. Plus some m here. So we just need to find the point here that is tangent, yes, which is what we did. We find this. So this, the intersection of this and the circle. The point on the circle where this and this are the same. P is negative 19/3. P is negative 19/3. Negative 19/3 minus. Okay, so I'm just making it worse. Minus. Okay, so if it's minus 19/3, then we just have all this. We just need to solve. We just need to solve. Well, we're going to have two values. It's clearly going to be larger than 7 and larger than 3. It's going to be, our point is going to be 7 plus delta x and 3 plus delta y, and root of delta x squared plus delta y squared is equal to 8, so delta x squared plus delta y squared is equal to 64. Okay, so if we replace y with 7 plus delta x, or 3 plus delta y, and x with 3 plus delta x, so 3 plus delta y is equal to 4/3 times 7 plus delta x minus 19/3. Okay, if we simplify this, we get delta y is equal to 4/3 delta x. 4/3 times 7 is 28/3. 28/3 minus 19. 28/3 minus 19/3 is 9/3. 9/3 is 3, so we just have this. Delta y is equal to 4/3 delta x. Oh my gosh. Delta x squared plus 4/3 delta y squared is equal to 64. So delta x squared plus 16/9 delta x squared is equal to 64. 25/9 delta x squared is equal to 64. Square root of both sides, 5/4. X squared is equal to 64. no, it's 5/4 delta x, so delta x is equal to 256 over 4 over 5. Okay, cool. So our solution is we have an x value. X is equal to 7. Wait, what? 7 plus 256 over 5. 7 plus 256 over 5, and y is equal to 3 plus delta y is delta y, we said, was 4/3 x. So delta y is 4/3 x. So 4 times 256 is 128, 124 15ths. I have a really bad feeling about this one. So we have 3 plus 124 15ths is equal to negative 3/4. So negative 3/4 times 7 plus 256 over 5 plus m. So m is going to be equal to 3 plus 124 over 15 plus 3/4, so 21/4, and then 256 over 4 is 64/5 plus 64 times 3 is 192. Yeah, no. This isn't the answer. It's supposed to be a positive integer, but we're just gonna go with it and check what the actual answer is. The actual answer is 73. They said the objective function to be maximized, or the equation, yeah, can be written as a circle, radius 8, yeah, got the correct circle. The objective function can be 3x plus 4y equals a, written as, yep, did I think I messed it up entirely from here. This should be m over 4. So this should all be over 4. Or times 4? Yeah. The value of a when a is maximized to the line is tangent to the circle at point P. Note that the slope is 4/3, which gives, okay, we're gonna zoom out. So holy cow, I did a lot. This is correct. I got the entire thing incorrect. The entire thing incorrect. This part is correct. This is incorrect. This part is correct. This part is correct. This part is correct. This part is correct. So they got different coordinates of point P, which is probably where I went wrong. With the radius being 8, yeah, therefore the y-intercept of the line is, okay, cool. Okay. Method 2, use the quadratic discriminant. So from this, we get, from maximizing the equation, we get maximizing line. Substituting into the circle, we get a very big thing. Maximum, this equation's discriminant is 0, which gives an equation for a. After simplification, a squared minus 66a minus 511 is equal to thing. Cool. So they, interesting. Okay. Well, I didn't get it correct, but I got portions of it correct. I just did not know where to go from here. That was a lot. Cool. Thank you for watching. I will see you guys tomorrow. Goodbye.